All right, we're going to talk about power systems in your trailer, how they work, and all the components. So you basically have two power systems in your trailer: the 120 volt AC power system and a 12 volt DC power system. The 120 volt AC power system is supplied by shore power from a pedestal in the campground, an outlet at your house, a generator, feeds power into the breaker panel inside your trailer, and then that power is fed through circuit breakers out to your loads. Those loads would be the air conditioning, the microwave, the fireplace. Your outlet circuits could be 2 or 3 different circuits there. Your electric element in your water heater, if you have a gas propane electric water heater, and your converter. So those are all the circuit breakers you'll see in this panel supplying these loads. Some other things you might think of that are 120 volt AC are the refrigerator, the heating, the element in the refrigerator. If you have a propane electric refrigerator that runs on shore power, it has an electric element that runs off of 120 volt AC. If you have recliners, they're plugged into an outlet. That's 120 volt AC. Your television is 120 volt AC. But all these things plug into an outlet, one of these outlet circuits. So you won't find a circuit breaker for your television or your refrigerator or your recliners in your AC breaker panel. The water heater and the air conditioner both require 12 volt DC also. They have to have 12 volt DC power to run. So they need both 12 volt DC and AC power. Your 12 volt DC system, which can get power from various sources that we'll go over in a little bit, supplies all the loads you need to set your camper up and break your camper down so you can travel with it. Everything you need for hot and cold running water, your lights, your refrigeration, your in-command system to run everything, to operate your slide outs, your awnings, your leveling system, your furnace. All that stuff is 12 volt DC. So you can go camping, boondock, and you have everything you need from 12 volt DC from your battery. So in your fuse panel, which is right next to your breakers, if you'll open the cover, you'll see the breakers and the fuses right in the same panel. So your breaker panel is 120 volt AC with the circuit breakers. All the fuses are 12 volt DC loads, all that stuff. Some of the DC loads come off of auto resetting circuit breakers up in the tongue area on the older trailers or the newer trailers with the Giggy box or the Brock box. They'll be inside those boxes. We'll go over what those loads would be. So those are your two systems, 120 volt AC, 12 volt DC. So let's go through how everything is connected together. So your shore power is coming into your breaker panel here. It's feeding all these loads. And one of those loads is the converter. So the breaker for the converter is supplying power down to your converter. The converter on the is just a big DC power supply, regulated DC power supply used to supply 12 volt power to these loads, and it also supplies power to charge the battery. On a 50 amp trailer, the converter is located behind the breaker panel on the floor. On a 30 amp trailer, the converter is located underneath the breaker and fuse panel, right underneath it. The converter outputs 12 volt DC power, which is actually 13.2 volts to about 14.4 volts, depending on what mode it's in and what kind of converter you have. So that's the DC voltage output of the converter. And it goes through some reverse polarity fuses. So on the 50 amp trailers with the separate converter, those fuses are right on the converter. On the 30 amp trailers, those reverse polarity fuses are on the fuse panel, 2 red 40 amp fuses you'll see. Those fuses are there to protect the converter from reverse polarity. So if you hook up your battery backwards, even for a second, it's almost like a short circuit. It feeds back in through here to your converter, and these fuses will blow to protect the converter. So if you have a problem with getting no output from the converter, you may have blown these fuses, especially if you hooked up the battery backwards for even a second, it'll blow these. So the power from the converter comes out through these fuses to your fuse panel loads. Most of those loads are getting supplied from power here. Now on this fuse panel, you'll see little red lights. If there's a blown fuse, a little red light will light up. And that's a blown fuse indication. That tells you that that fuse is blown. That only works if you have a load attached to that fuse that's turned on trying to run. If there's something that's attached to it that's not turned on, like a light or something where there's no load, that blown fuse indication won't come on, but the fuse could be blown. So if you see a red light in the fuse panel, that means you got a blown fuse, but it doesn't necessarily mean you'll see a red light for every blown fuse. If that's not confusing, sorry. So your DC power comes in from your converter, powers that all up. It's also going to feed back up through here, and it'll charge the batteries. So the other source of power to your 12-volt DC system is from your battery then. Let's come this way. Your battery supplies power. And on the older trailers, pre-2019 trailers, 2018 and earlier, they had a single battery disconnect switch. They didn't have the Giggy boxes or the Brock boxes. So your battery fed down here, and it was feeding some auto-resetting circuit breakers that were just mounted on the tongue of your trailer out in the open, or in the fifth wheels just mounted on the wall behind the breakers. And one of those breakers is a 50 amp breaker, and the battery fed down through there, through that breaker, and it had the old battery disconnect switch. And that battery disconnect switch was in that line going from the breaker on the tongue to your DC fuse panel. So it only disconnected this. It didn't disconnect all this other stuff up here that we're going to talk about in a minute. So that's the difference between what used to be and what they have now. In 2019, they started installing Giggy boxes on the travel trailers, and in 2022, they started installing the Brock boxes on the fifth wheel trailers, named after Mr. Giggy and Mr. Brock, the people who designed them. And basically what they did was they took these auto-resetting breakers that were just sitting out in the weather on the tongues of the travel trailers or just mounted to the wall, and they put them inside of a box to protect them and make it more organized, make the wiring more organized. So that's why they did that. So nowadays with the Giggy box or the Brock box, you have your battery coming in here, and this is your battery disconnect switch. So on the Giggy box or your Brock box, that red knob where you can turn power on and off, or remove the knob to actually turn it off and pull the knob off. That's your battery disconnect. That is the switch that actually disconnects the battery from everything in the trailer. Okay? So when you're looking to turn off the battery disconnect switch, that's the battery disconnect switch. You'll have two other switches, one or two other, depending on the age of your trailer. You'll have an inverter disconnect switch up here, which we'll talk about later. That's disconnects, that's just for the inverter. And some of the newer trailers, 2023 and later, have a PV disconnect switch, which we'll talk about in a little bit. But those are not battery disconnects. They have nothing to do with disconnecting the battery from the trailer. They're separate for the individual loads. So on the Brock box or the Giggy box, the battery's coming in. And right here is your battery disconnect. So with the battery disconnect on, power's coming down through here, and it connects up to here. And you'll have, if you pull the cover off the boxes, you'll see these little silver boxes, or circuit breakers, auto-resetting circuit breakers. And they're feeding some of your bigger loads. So the slide out, the tongue jack, your tank heaters, your auto leveling, those things are all coming off of circuit breakers inside your Giggy box, and then you'll have this one 50 amp circuit breaker, which is supplying power down into the fuse panel in your trailer. Again, this, if you have a newer trailer with the Giggy box, you won't have this old disconnect switch, so this will just be a solid wire here. So the bigger loads are coming off of these circuit breakers up there. You also have your 7-pin cable coming from your truck, feeds in here, and the charge line from your truck ties into there, so that's another 12-volt source into your trailer, into the power system to charge your batteries or supply loads. Your running lights, your brake lights, your turn signal all that wiring comes into the box but goes right back out to your lights, and that's all powered up from your truck. All your trailer running lights and that is powered from your truck. So the only wire that goes and connected to the trailer is your charge line from your truck. Now, if you have the battery disconnect switch turned off, like that, say, so the power can't flow down through here now, so you've turned it off. So you see the battery comes down. The only thing, there's three things connected to it when the battery disconnect switch is turned off. Your emergency breakaway switch power. So if your trailer breaks away from the trailer, your trailer breaks away from the truck, pulls the pin out of your breakaway switch, it'll apply power from your battery to your brakes to lock them up and stop your trailer. The other things that are connected are your solar port on the side of your trailer for hooking up a portable panel. It just plugs in there, goes through a 15 amp fuse, and it's connected right there to the battery. It's always connected. And then if you have your solar panels, come in through another circuit breaker here, 30 amp circuit breaker, and that's also always connected to the battery. So when you have the battery disconnect switch on or off, all that stuff is always connected to the battery, and it's charging the battery no matter what position this battery disconnect switch is on. So that's the basic AC-DC power systems. Every trailer has the AC power system and this DC power system. And that's how they're all connected and how it all works. So now let's talk about the other things that you might have if you have solar. The 200 Solar Flex 200 packages, or the newer ones, or the 400 packages. We won't talk about the 600 because that's a different animal. But you'll have your solar panels. If you have the Solar Flex 400 package, you'll have a smart shunt and you'll have an inverter. Those three devices are completely separate and independent of each other. You can have one without the other. They're not interconnected. They all do separate things. They're all separate and independent. So let's talk about solar. You have your solar port on the side of the trailer. You can have a portable panel with a charge controller. You need a controller, and you would plug that into your port, and then that would power right into here to supply power to charge your batteries, or with the battery disconnect closed, it's going to supply power into the trailer, and it'll go to supply loads, or it'll charge your batteries, whatever it needs to do. And then if you've got your solar panels on the roof, you've got 200 or 400 watts or whatever, and they're generating DC power. So the newer panels come out around 40 volts DC, and it comes down into your solar charge controller. Now in the newer trailers, 2023 and later, they started installing this PV disconnect switch. It's a photovoltaic disconnect switch. It's just there to disconnect the output of the solar panels going to the solar charge controller. So that's all it does, just opens, circuits the output of the panels. So if you want to do something with the charge controller, or there's a problem, you can open this switch and disconnect the panels and do what you need to do with the charge controller. So it's not a battery disconnect switch, just like the inverter disconnect is not a battery disconnect. It has nothing to do with the battery feeding power into the trailer. Simply disconnects the panels from the solar charge controller. Normally you leave it on all the time, really never a reason to turn it off. Said the older trailers before 2023 never had this switch. It was just hardwired. So your panels are putting out 40 volts. Well, you can't charge your battery with 40 volts. You can't run your 12 volt DC loads with 40 volts, so you need something to change that. So that's what the solar charge controller does. It's a regulator. It takes that 40 volts input and turns it into a usable voltage from 13.2 to 14.6 volts is what's coming out of here. So on the Victron, if you have a Victron controller, which all the new trailers do, you can download the Victron Connect app and Bluetooth connect to the solar charge controller and adjust the battery settings so that they are proper for whatever battery type you have. You want to check those and make sure you have the right settings in there so it's charging it properly. So the power comes out of the charge controller, comes over here into your Giggy box through a circuit breaker, and it connects into there. And like I said, it's always charging the battery. That's not, there's actually no way to disconnect the output of the charge controller except for disconnecting the wires at the charge controller. So that's your solar. It's always it's doing its thing. It's independent of the smart shunt, has nothing to do with that, nothing to do with the inverter. It's making power and providing it to here, and it'll charge your batteries, or with your disconnect switch closed, it's just another source of 12-volt power to your trailer, and it will come in here and supply your loads also. Hey, your smart shunt is a battery monitoring device. So its purpose is to provide indication of the state of charge of the battery. It's located in the negative lead from the battery. It goes from the negative terminal of the battery to the trailer frame. Without a smart shunt, it's just you'll find that's just a piece of wire, so they stuck this smart shunt in that line. And what it does is it sees everything coming into and going out of the battery. So there's only one thing that should be connected to the negative battery terminal, and that's the smart shunt. Everything else should be connected to this side of the smart shunt so that it sees everything. So all your loads, like your inverter, your solar, your converter, your battery, everything, everything has a frame. Everything goes to the frame on the negative side. So has to flow through the smart shunt. Your smart shunt needs 12-volt DC power to run because it's a computer. It's basically a little calculator, and has Bluetooth, so it needs power. So it has a little 12-volt supply with a little 1 amp fuse. I think it's a 1 amp that will supply power to it. The smart shunt is located in the inverter disconnect box on the travel trailers. So the box with the inverter disconnect switch that's located right directly behind the batteries is where the smart shunt is located, inside that box. That fuse is either inside the box, or there's a fuse holder on the front of the box, and that's what that fuse is. There's 2 or 3 different styles of boxes, so they're all different. Some of them have the fuse external, some of them the fuse is inside. But that's where the smart shunt lives. So the smart shunt's looking at the power coming into and out of the battery. It's monitoring that, and it'll tell you the state of charge. Now, the smart shunt doesn't measure state of charge. It's not like a voltmeter where you hook it up to the battery and it tells you that the battery's at 50% charge. It doesn't know where the battery is until the battery gets to 100%, and then it can start counting how many amps are coming out or how many are going in. So once the batteries are fully charged, then it totalizes. Basically, it looks at amps going out of the battery, and it starts taking those away from the 100%, and your state of charge will go down. If you start charging from your converter or your solar, and you start putting battery power back into the battery, then it'll say, I'm getting positive current flow into the battery, and your state of charge will go back up. But it has to start at 100% to be able to know where it is. It doesn't, like I said, it doesn't measure like a voltmeter. You can't hook it up to the battery, any battery, and find out what the state of charge is. It has to start from a known state of charge, and then it calculates based on inputs and outputs what the state of charge is from the battery. Same thing with the smart shunt as a solar controller. Your Victron Connect app, you can Bluetooth connect to the smart shunt, and you have to set the battery settings up properly to match what kind of battery you have, so the smart shunt knows how to do the calculations properly to tell you what the state of charge is. So if you haven't set the battery settings up, the state of charge on that is worthless, because it doesn't know what's going on with what kind of battery you have and everything. So very important, you got to go in there and make sure your settings are correct. So that's the smart shunt, a battery monitor. That's all it does. It doesn't do anything to the solar. It doesn't control anything either. So it's just a monitoring device. It's just sitting there passively monitoring what's going in and out of the battery. Doesn't have any control functions. It doesn't do anything else. It just sits there and watches the battery. Okay, the other thing you'll have is the inverter. So an inverter takes 12-volt DC power, and in and makes 120 volt AC power out. So let's put this switch over here, wherever my pin is. So your inverter takes 12 volt DC power, goes through a big old honking fuse, like a 250 amp fuse. Then it goes to the inverter disconnect switch. So like I said, on the travel trailers, it's in the box right behind the batteries. And on the fifth wheelers, it's just right next to the, located by the inverter, separate switch. Goes through there. That disconnect switch simply disconnects the DC input to the inverter. That's all it does. So it's there basically to meet code and provide a means of power disconnect. If you want to work on the inverter or there's a problem, you can turn that off to kill power coming in. Normally it's always on, really no reason to turn it off. You control the inverter on off by its own power button on the inverter. So that's what the inverter disconnect switch does. Doesn't do anything to disconnect the power from the battery to the trailer or anything, so don't get confused with that. Now your inverter has two pieces of it. Your inverter part, which is what takes your 12 volt DC in and makes your 120 volt AC out. Also integrated into the inverter is an automatic transfer switch. So normally that switch preferentially selects shore power to supply these outlets. So the inverter is just supplying a string of outlets, that's it. Those little outlets with the yellow stickers on them is all it supplies. It's not supplying an air conditioner or a microwave or your fireplace or anything like that. It just supplies that string of outlets, which may include, it does include the one that has your TV and plugged into it. So that's why you can run the TV when you're boondocking and you don't have shore power. So normally, when the inverter is on or off and you have shore power connected, inside your breaker panel you'll see a breaker labeled invert, INV, or solar, something like that. That's the breaker that's supplying the power through the inverter to this outlet string. So it's really just one of these outlet strings that I mentioned earlier. That's all it's doing. It's a breaker. It says inverter or solar. But what happens is it supplies shore power up and it just passes through the inverter. Normally this transfer switch is selected so shore power passes through and it goes up through here and out to your outlets. So whether the inverter is on or off, when you have shore power just passes through the inverter to supply the outlets. Now if you have the inverter turned on and you lose shore power, this transfer switch flops over automatically like that. So if you have the inverter turned on and you lose shore power or you don't have shore power, now the transfer switch is flopped over like that. Your inverter supplies power to your outlets. And that's how the inverter works to supply power. If you turn the inverter off, this transfer switch flops back to shore power and you'll have no power out if you don't have shore power. So only when you're off grid with the inverter turned on will that transfer switch flop over and let the inverter supply power. When you're on shore power, it's supplied from shore power, passes right through. The inverter is not in play. It's not even in the circuits. The inverter takes, it's a 10-to-1 ratio for, since it's 12 volts in, it's 120 volts out, that's 10 to 1. So a 10 amp load on the AC side, like you got a hairdryer plugged in or a coffee pot, means that you're drawing over 100 amps on the DC side from the battery. So 10 to 1 ratio. If you have a 100 amp hour battery and you have a 100 amp load, that means in an hour you're going to deplete that battery completely, if not a little sooner. The inverter does have a shutdown on it at 10.6 volts, so if the battery voltage is too low, the inverter will shut off. It also has a power save timer on it, which has a default setting of 24 or 25 hours. So if you turn it on and then you come back the next day and for some reason you're boondocking and the inverter turned itself off, it's that power save timer automatically shuts it down after 25 hours if there's not enough load. So you have to go to the inverter, push the power button off and on to get it turned back on. So that is how the power system all works, how all the different components interface each other. Once again, solar is solar, smart shunt is smart shunt, inverter is the inverter. Separate and independent devices. They do different things, different functions. They don't rely on each other, don't require, you can have one without the other. So hopefully that clears things up, and any questions, drop them in the comments, and we'll see what we can do. Thanks.